This video will describe all operating modes of the actuator. In this video, the unit of current is mA. The speed is the motor speed. The unit is RPM. If you need to calculate the motor speed from the speed of the reducer, just multiply it by the corresponding reduction ratio. The unit of position is count, that is the encoder count. The motor and reducer both use 16-bit encoders. After one rotation, the encoder count is 65536. So to calculate the target position value based on the angle, you can use the formula .target target position, set 5536, target angle, NAR 360. If the value of the position mode selected encoder parameter is motor, target position must also be multiplied by the actuator's reduction ratio. Asynchronous mode is used during production for calibrating the motor side encoder, allowing the motor to rotate without relying on sensors. Under normal actuator conditions, users are advised to avoid using this mode. This mode is primarily provided for remote encoder calibration. Open loop mode is used during production for calibrating the reducer side encoder, enabling simple motor rotation. Under normal actuator conditions, users are advised to avoid using this mode. This mode is primarily provided for remote encoder calibration. Current mode directly controls the actuator phase current. This area is the control section for current mode. Users can drive the motor by pressing buttons or entering specific current values. When debugging in current mode, please start with a small current and gradually increase it. Otherwise, it may cause danger. This area allows manual control of the brake's lock and release states. Please do not modify the voltage and hold time value. The middle shows the state change curve of the actuator. Click the Stop Plot button to stop drawing the curve graph. This area is where some of the actuator status is displayed. By checking or unchecking the corresponding status, you can decide whether it will be displayed in the curve graph. Enter the current value. The actuator adjusts the current to the target value. You can also use the following buttons to send the target current directly. To change the rate of current change, you can modify the PID value of the actuator current loop once or in real time. Profile velocity mode controls the rotation velocity of the actuator. Profile velocity mode can control the current limit value and motor velocity at the same time. Enter the velocity value and send it. The actuator rotates according to the target velocity. Note that if the current limit value is set too small, the target velocity may not be achieved because the current is not enough to provide the required driving force. If you want to change the velocity change rate, you can change the value of velocity mode acceleration, deceleration. The velocity loop PID is used to adjust the effect of the actual velocity following the planned velocity trajectory. These support one-time modification or real-time modification. For specific setting methods, please refer to the Modify the PD parameter document or the parameter setting video. The profile position mode is used to control the position of the actuator and has built-in trajectory planning function. When entering the profile position mode, the system will automatically return to 0 by default. This can be changed in the motor parameter settings. This mode can control the current limit, motor velocity and reducer position at the same time. Note that if the current limit is too low, the motor may not be able to reach the set velocity. So make sure that the current limit meets the load requirements. Enter the target position value, and the actuator will move to the target position, according to the planned trajectory. Notice before the previous trajectory planning is completed, the update position command sent will be ignored. It supports one-time modification or real-time modification of the acceleration and deceleration parameters in this mode, or the PID of the current loop, speed loop, and position loop. For specific setting methods, please refer to the user manual. When exiting, the brake will automatically lock. Different from the profile position mode, the position mode does not have built-in trajectory planning, so it allows high-frequency position updates and requires trajectory planning in the upper layer. Since there is no trajectory planning, once a target value is entered, the actuator will move to that position at the fastest velocity. MIT mode is a control method that can achieve mixed control of current, velocity, and position. The MIT mode has 5 parameters, among which des and vdes are the input values of the position loop and the velocity loop respectively. Kp and Kd parameters are used to adjust the stiffness and damping of the motion, and the output value of the position loop. The output value of the velocity loop and the feed-forward currents Ff are added to obtain the reference currents ref. The control instructions of this mode need to be sent in 2 CAN frames. One frame is the motor current, velocity, and reducer position, and the other is Kp and Kd, but both are optional. Here are a few examples of usage. 1. When both Kp and Kd are 0, it is equivalent to the current mode, and the current can be directly controlled. 2. When Kp is 0 and Kd is not 0, the input current and speed value can control the actuator rotation speed, and the current value is used for feed-forward torque compensation. 3. When both Kp and Kd are not 0, there are multiple situations, and 2 are introduced here. 1. The input speed value is 0. The current and position are not 0. The fixed point control is achieved. 2. When current, speed, and position are not 0, when the desired position is a differentiable function that changes with time, and the desired speed is the derivative of the desired position, then position and speed tracking can be achieved, and the function of rotating the desired angle at the desired speed can be achieved.